5.3 Sum and Difference Identities. So the sum and difference identities for cosine, we have cosine A plus B equals cosine A, cosine B, minus sine A, sine B. And then if we have cosine A minus B, it's just the opposite of that, cosine A, cosine B, plus sine A, sine B. Example 1, finding exact cosine values. So let's find the exact value of cosine 15 degrees. So why do we do this? Why are we finding the exact value of cosine 15 degrees? Why aren't we just using the unit circle? Well, because if we wanted to find cosine 15, the exact value, we cannot use our calculator because exact value means no decimals or anything like that. But what can we do to find cosine 15? So that's where this a plus b, a minus b comes in. So I want to find two cosines that either add or subtract to 15 degrees. If we look at our unit circle, we're just going to look for two numbers that either add or subtract to 15 degrees. Now, since 15 is a smaller number, we're going to subtract to it. Now, any two numbers, literally any two numbers that subtract to 15. So you could use 315 and 300. You could use 225 and 210. But let's keep with easy numbers. Let's try easy numbers. How about 45 and 30? If we subtract those, we get 15 degrees. So we're going to be using cosine 45 and cosine 30 to get cosine 15. If we subtract those, we get cosine 15. So cosine 15 degrees, we know we can get that by doing cosine 45 degrees minus 30 degrees. That does give us cosine 15. If we simplified it, cosine 45 degrees minus 30 degrees is cosine 15 degrees. So nothing's changed. It's still the same value, it just looks different. So the numbers haven't changed, just the look of it. So since we're doing minus, since this is a minus right here, we're going to be using cosine A minus B. So we're going to be using the A minus B formula, which is cosine A cosine B plus sine A sine B. These identities are actually really easy to memorize because they're all the same. It's just whether is it a plus or a minus. So write it out every time you use the formulas. And for cosine, sum or difference, if you're adding, you're going to be subtracting in the equation, and if you're subtracting, you're going to be adding. So it's always going to be the opposite. So you see how this is subtraction? That's why this is a plus. So it's always going to be that opposite. So what is A? What is B? Well, that's what we got for the 45 and the 30. So that's our A and that's our B. So let's plug it in. Let's plug it back in. So we have cosine A, which is 45 degrees. And then we have cosine B, which is 30 degrees. And then that's plus sine A, so sine 45 degrees. And then sine B, so sine 30 degrees. So the reason why we do this, because we actually have these values on the unit circle. We have these exact values. We have the values of cosine 45, cosine 30, sine 45, and sine 30. You're going to use your unit circle. So looking at your unit circle, I'm not going to switch back. You guys have your unit circle. So looking at our unit circle, cosine 45 degrees is square root of 2 over 2. Cosine 30 degrees is square root of 3 over 2. Plus, and then sine 45 degrees is square root of 2 over 2. And then sine 30 degrees is 1/2. So from here we simplify by multiplying straight across. So we have square root of 6 over 4 plus the square root of 2 over 4. So now they have both the same denominator, so we write it over one denominator now. So we have square root of 6 plus square root of 2 all over 4. So cosine 15 degrees equals square root of 6 plus square root of 2 over 4. Alright, B, we have cosine 5 pi over 12. So when we're talking about radians, it's a little more difficult to use the unit circle because we need to find two fractions that add to 5 over 12 with a pi in there. So it's a little more difficult with radians, but we'll get there, don't worry. So you're going to be looking in quadrant 1. Most of the time you want to try and work with the smallest numbers possible on the unit circle. So let's look at quadrant 1 and see if we find anything that can add up to 5 pi over 12. Alright, so looking up at our unit circle, none of the denominators are 12. but all of them can become 12. So if you look at all of our denominators, 6, 4, 3, they're all 6, 4, and 3, by the way, then those all can be 12 if we multiply to them, because we could make 3 12, we can make 4 12, we can make 6 12 by multiplying numbers. So let's make the first quadrant have denominators of 12. So using our unit circle, let's make denominators of 12 in the first quadrant. So for our first one, if we wanted to make the denominator 12, we'd multiply by 2. So times 2 times 2. So we would have 2 pi over 12. For pi over 4, we multiply by 3 times 3. So for pi over 4, it'd be 3 pi over 12. And then for pi over 3, we multiply by 4. So then we'd have 4 pi over 12. Now, if we put any of those together, can we get 5 pi over 12? Yes, we can. We can. If we use pi over 6 and pi over 4, that gives us 5 pi over 12. Because 3 pi, 2 pi, that's 5 pi. So the two numbers we're going to use are pi over 4 and pi over 6. Alright, so using our unit circle, we determined that cosine pi over 6 plus pi over 4 gave us that 5 pi over 12. But let's just put back in here how we got 5 pi over 12. So if we did pi over 6 plus pi over 4, so times 2, and then times 3, we would have 2 pi over 12 plus 3 pi over 12, which is 5 pi over 12. So that's how we got to use pi over 6 and pi over 4. So that's our A, that's our B. So since we're doing cosine A plus B, we're going to be using cosine A plus B, because that's what we're doing, and that's going to equal our cosine A, cosine B, minus sine A, sine B. So we have our A, we have our B, let's go ahead and plug it into our formula. So we have cosine A, which is pi over 6. Then we have cosine B, which is pi over 4. And that's minus sine A, which is pi over 6. And then sine B, which is pi over 4. Now we use our unit circle to find cosine pi over 6, cosine pi over 4, sine pi over 6, sine pi over 4, and we know how to do that. So when we do our cosine pi over 6, we get square root of 3 over 2. Cosine pi over 4 is square root of 2 over 2, minus sine pi over 6 is 1/2, and then sine pi over 4 is square root of 2 over 2. We simplify, we multiply straight across, so square root of 6 over 4 minus square root of 2 over 2. So then our final answer is square root of 6 minus square root of 2. Sorry, that's over 4. All over 4. Part C. We have, this is what we're given. Cosine 87, cosine 93, minus sine 87, sine 93. That's what we're given, and we need to find the exact value. So right now, we're given the right side of the identity. We have now this side. We have this side of our identity. Since we have that side of the identity, we just need to go to the other side. We need to go to this side. In example A and B, we have this, and we need to get to here. So we're just going the opposite way now. We can use either side of the identity. And identity means the left side and the right side are the same. That means we can use the left side or the right side, depending what we're given. So since we're doing cosine minus, we have cosine, cosine minus sine, sine. So that means this came from, originally, this came from cosine A plus B. That's where it came from, because it's the minus. The A and the B are the numbers that we're given. So we have cosine A, which is 87 degrees. And then we're going to add that to B, which was 93 degrees. So we do 87 plus 93, and we get cosine 180 degrees, which we can simplify because 180 is on the unit circle. Since it is on the unit circle, we get -1. Alright, cofunction identities. So we've talked about these already. We're going to use them again. So remember, it's cosine 90 minus x equals sine 90 minus x equals cosine x, tan x, or tan 90 minus x equals cotangent x, and then the reciprocals of those. So remember that you can either use 90 degrees or pi over 2. It just depends if you're working in radians or if you're working in degrees. But 90 and pi over 2, remember, they are the same exact thing. So we're going to use cofunction identities to find theta. So find one value of theta or x that satisfies each of the following. So we want to solve for theta with cotangent theta equals tangent 25 degrees. So basically, we want to get these to both be tangent using cofunction identities. So let's just rewrite A. So we have cotangent theta equals tangent 25. What you're going to replace is the function that has no number. So you see how we have cotangent theta and then tangent 25? Do not touch tangent 25. We're going to switch out the cotangent theta because that's going to allow us to make it all tangent. Because cotangent theta, we know this. We know cotangent theta equals tangent 90 degrees minus x. So we're going to switch this to tangent 90 degrees minus x, and that equals tangent 25 degrees. So we're now allowed to solve this because they both have tangent functions in them. So the tangent functions, because they're on opposite sides, they cancel each other out. So we're left with 90 degrees minus x equals 25 degrees. Let's solve for x by subtracting 90. So we have negative x equals negative 65 degrees. So we have x equals 65 degrees. X, theta, all the same thing, but we're actually finding theta, so let's switch this back to theta. Alright, so for B, we have sine theta equals cosine negative 30 degrees. So remember, do not touch the one that actually has the number. You're going to touch the function that doesn't have the number because that's how we're going to solve it, because we replace it. So I want you to go ahead, pause the video, and try B. Welcome back. So because we have sine theta equals cosine negative 30, let's look at our cofunctions and replace sine theta. We replace sine theta because it doesn't have any numbers there. So if we look at sine theta equals cosine 90 degrees minus theta. So we're going to replace sine theta with cosine 90 degrees minus theta equals cosine negative 30 degrees. What that allows us to do, it allows us to get rid of the functions because they're on opposite sides of each other, so they cancel out. So what we have left is 90 degrees minus theta equals negative 30 degrees. We solve for theta, so we get theta equals 120 degrees. Part C, we have cosecant 3 pi over 4 equals secant x. So remember, you're not going to touch the function with the numbers. Touch the function without the numbers. So the function without the numbers is secant x. So let's replace secant x and see if we can do it. So secant x has to have cosecant in it. So going back to our cofunctions, we have it right here. We have secant x equals cosecant. So we're good. We can use that. So we're going to switch our cosecant. So we're going to switch our secant to cosecant. So our cofunction identity would be cosecant, not 90 degrees because we're not working with degrees here, we're working with radians. So it would be pi over 2 minus x. Remember, x goes with radians, theta goes with degrees. That is the truth. Alright, we can cancel out our cosecants because they're on opposite sides of each other. So we have 3 pi over 4 equals pi over 2 minus x. We solve for x by subtracting it over. So we get our theta equals negative pi over 4. You guys know how to solve for variables by now. So something that's going to come back later on. Because trigonomic functions are circular functions, they're periodic, the solutions in example 2 are not unique. We give only one of the infinite many possibilities because it goes on forever. There's no restriction on this domain, so it just keeps rotating and rotating and rotating. So you could find literally every angle that could create. We just found one unique one, but there's infinite amount. And when later through the semester, we'll actually find how do we find those values? because we can't spend all day just being like, okay, it's this, and this, and this. No, we'll come up with an answer to help us find the infinite amount of answers that it actually is. Applying sum and difference identities. If either angle A or B in the identity for cosine A plus B and cosine A minus B is quadrantal angle, then the identity allows us to write the expression in terms of a single function of A or B. So meaning if we have a degree of 0, 90, 180, 270, 360, and so on, all of those quadrantal angles, we can simplify this in a different way. Alright, so we're going to write cosine 180 minus theta as a trigonometric function of theta alone. So basically we want to get this all simplified nice and neat. So we have cosine A minus B, because it doesn't matter what A and B are. We have an A, it's a minusing a B. So we have cosine A minus B, which that formula is cosine A, cosine B. Since it's minusing, we're going to plus sine A, sine B. And we have our A, and we have our B. So let's go ahead and plug them in. We have cosine A, which is 180. Cosine B, which is theta. Plus sine A, which is 180. And then sine B, which is theta. So we're going to simplify because cosine 180 on the unit circle is -1, and then cosine theta is just cosine theta. Sine 180 on the unit circle is 0, and sine theta is just sine theta. So we have 0 times sine theta, that goes away. All we're left with is -1 times cosine theta, which is negative cosine theta. Example 4. Finding cosine s plus t given information about s and t. So suppose that sine s equals 3 over 5, and cosine t equals -12 over 13, and both s and t are in quadrant 2. Find cosine s plus t. So let's break out what it wants us to find first. It wants us to find cosine s plus t. So cosine s plus t, that's just a plus b. So we have s plus t equals cosine s cosine t, and then since it's adding, it'll be minus sine s and sine t. So we need to find those values of cosine s, cosine t, sine s, and sine t. We actually have some already. Some were given. We have sine s, so we don't need to find that. And we have cosine t, so we don't need to find that. But we need to find cosine s and sine t. So let's find cosine s first. Why first? Just because it's first. No other reason. So let's find cosine s. So we need to find cosine s. What other s's do we have? So other s's that were given. Other s values that were given is sine s equals 3 over 5. So if we have sine and we need to find cosine, we're going to use our Pythagorean identity. So we're going to use cosine squared theta plus sine squared theta equals 1. But instead of theta, because we're working with s, we're just going to switch this to s. Means the same thing, means the absolute same thing. So we have cosine squared s plus sine squared s. Our sine, which we already got, was 3 over 5. That equals 1, so we simplify. So we have cosine squared s plus 9 over 25 equals 1. We subtract 9 over 25, so we have cosine squared s equals 16 over 25. We square root. So we have cosine s equals positive negative 4 over 5. Now, is it positive? Is it negative? Well, we're working in quadrant 2. Remember, we're working in quadrant 2. So cosine in quadrant 2, using cast, cosine is negative in quadrant 2. So we have cosine s equals negative 4 over 5. Alright, so we found our cosine s. All that's left is the sine t. So let's find sine t. So let's look for any other information that's given that has t in it. So anything given that has t in it, that's the cosine t equals negative 12 over 13. So whenever you're given cosine and you need to find sine, you're always going to use the Pythagorean identity. That's the theme of this entire semester, right? We really use the Pythagorean identity. It's that important. So we're going to be using the same Pythagorean identity, but instead of s, we're using t. So we have cosine squared t plus sine squared t equals 1. So we have cosine squared t, so that's negative 12 over 13. Squared plus sine squared t, which is what we're trying to find, equals 1. So we square it. We have 144 over 169 plus sine squared t equals 1. We subtract it over, so we're left with sine squared t equals 25 over 169. We square root. So we have sine squared t equals positive negative 5 over 13. Now, is it positive? Is it negative? Using cast. So using our cast, in quadrant 2, sine is positive. So our value for sine t is positive 5 over 13. Now we have all the values. Now that we have all the values, plug them back in. So we're going to plug them back in. We have cosine s, that's negative 4 over 5. We have cosine t, which was given, and that's negative 12 over 13. Then we're going to subtract that to sine s, which was 3/5. And then we're going to multiply that to sine t, which we just found of 5 over 13. From here, we simplify our equation. So we have negative 4 times negative 12. So negative 4 and negative 12, we get positive 48. 5 times 13, we get 65. Minus 15 over 65. So we're left with 33 over 65. So cosine s plus t equals 33 over 65. Example 5. Applying the cosine difference identity to voltage. Common household electrical current is called alternating current, AC current, because the current alternates direction within the wires. The voltage V in a typical 115-volt outlet can be expressed by the function V of t equals 163 sine omega t, where omega is the angular speed in radians per second of the rotating generator at the electrical plant, and t is the time measured by seconds. A. It is essential for electrical generators to rotate at precisely 60 cycles per second so household appliances and computers will function properly. Determine omega for these electric generators. B. We're going to graph V in the window of 0 to 0.05 by negative 200 to 200. And then for C, I changed C. How many times does the current oscillate in 0.30 seconds? Alrighty, part A. So part A is asking us, it is essential for electric generators to rotate 60 times per second so the household functions properly. We want to determine omega for these electric generators. So we need to convert 60 cycles per second to radians per second. Why radians per second? Because that's what omega is. Remember, omega back in 3.4 is always in radians per second. So for our omega, we need to get this to radians per second. So we're talking about 60 cycles per second. Remember, per just means fraction. So then we need to multiply that by the radians. So remember, a radian, a full rotation, one cycle, because that's a rotation, is 2 pi radians for every cycle. And when we simplify that, we get 120 pi radians per second. That's our omega. So reaching back all the way to 3.4, I know it's been a long time, but that's where we're getting this from. Alright, so B. We want to graph V in the window of 0 and 0.05 by negative 200, 200. So our function that they gave us was v of t equals 163 sine omega t. So what we did is we just switched the omega for the value we actually found. We have omega. It's 120 pi. So with our calculator, I'll show you, we're going to press y equals, we're going to input the function 163, 120 pi t, or sine 120 pi t. Remember, the 120 pi, that was the omega. We're going to press window, our x minimum is 0, our x maximum is 0.05, our y minimum is negative 200, our y max is 200, and press graph. Now, why those numbers? Well, because that's the parameter it told us to graph in. These are our x values, these are our y values. That's our domain, and this was our range. It's always set up that way. So let's go ahead and do this with our calculator. Alright, so with our calculator, you're going to hit y equals in the top left. We're going to plug in our function, so 163 sine 120 pi t. So t, x, theta, they all mean the same thing. We're just going to put x. Now we're going to press window. It's on the kind of top second button. And we're going to switch this, so our x minimum needs to be 0. Our x maximum needs to be 0.05. Leave the scale as 1. Your y minimum is negative 200. And your maximum is 200. Leave your scale, your x, r, es, all of that below doesn't matter. All of that doesn't matter. Just make sure your scales and your maximum and minimums match. That's all. And then we hit graph. And there's our graph. What mode should we be in? We should be in radian mode. Why should we be in radian mode? Because we're working with radians. 120 pi, that stands for radians. And there's no degree in here whatsoever, so that's why we're in radian mode. And there's our graph. Nice, right? Does it match with the sine graph? Absolutely it does. So for B, let's talk about a few things about max and minimum voltage. So for B, we can get our maximum and minimum voltage. Remember, that's the amplitude. That's the amplitude. So our max voltage is 163. Our minimum voltage is negative 163. So that's the max. It could be anywhere between that. It can be 5. It could be 10. It could be 62. It could be 115. It could be 130. Doesn't matter. Just anywhere between negative 163 and positive 163. Alright, part C. How many times does the current oscillate in 0.30 seconds? So it tells us that we cycle 60 per second. So how many times if we do 0.3 seconds, we just multiply by 0.3. So 0.3 times 60, we get 18 times. So it goes around 18 times in 0.3 of a second. 0.3 of a second is not half of a second, by the way. That's not half. It's a third of a second. So a third of a second, it rotates 18 times.